Hello, folks, welcome back to Oxygen Not Included. Last episode, we tried to tame this magma or volcano, and unfortunately, this design of pump did not work. It could not detect liquid at the bottom, so it would not sucking it. So, right now, what I'm doing is I'm trying to revert back to a tried and tested design, but it requires us to get rid of all this junk that is there. So I put a mesh tile made out of steel here, so the plastic that I'm going to deconstruct does not come into contact with magma. And fingers crossed, we should be able to deconstruct this without ruining our perfect vacuum. I'm also connecting this power grid to our main power grid using this side. So this should unify all of our power grids, and I'm going to get rid of this coal generation area because now we can move all the coal generation over here, or coal power generation over here once duplicants finish this, but that's okay. We have plenty of time to spare. I'm just going to break it up in the meantime so that we can maintain a perfect vacuum, and then later on we can fill up this column with some other gases. Right now this is gonna be fully vacuumed. This is a different section because there is a liquid lock here. Okay, good, somebody has done that. Somebody come deconstruct this thing, please. Harold is here. Nice, Harold. Come on. You can deconstruct that. You can deconstruct the conductive panel as well. Good. And the temperature is not increasing, so that is good. We just changed the direction of the channel. Instead of coming from this side, we are going to come from this side because we need right hand side to put a blob of liquid for our pumps. So what I am going to do is just going to seal up on this side. It's fine. We just have one extra tile, but otherwise we'll just move all of our ranches a little bit to the right hand side. And oh, what, melted lead, yeah, that's my bad. Yeah, we can easily recover from that. All we need to do is just delete that lead. So to do that, I'm just going to compress this out and delete it. So compress it using obsidian, obsidian and obsidian, just diagonal building, and this way we can just remove that lead. Cancel this build, and once this tile gets built, it should destroy it. Good. Now we need to destroy it instantly because this overpressure is going to break that tile otherwise. Good. So the pressure should normalize back again and this overpressure damage should stop. We expanded our volcano tamer to on the right hand side. We just need to deconstruct this part so that we can mop up this magma and get rid of the steel. This steel is going to annoy the hell out of me, so I am going to take the risk, break it open, mop up all the magma, and then just seal it back. Plus this tile also got some damage due to overpressurization, so we can fix that too. We are almost ready to fire this up. What we did is we just connected our liquid pump using ceramic pipes all the way to this liquid filter. This filter is set to only allow magma. I haven't set in it, so only allow magma to go out this way. So this way magma is going to flow in this tank, and whatever is not flowing in the tank is going to come here and is just going to get dumped back on the liquid pump, and this is going to act like the coolant. Mopped up the magma and moved it through the pitcher pumps all the way over here, and I'm just going to seal this up just so that in case we have any messes we have a better chance of managing it. So let's see what the automation is. So this automation is currently set to, if anything is below, it will open up, it will let the magma through, and magma should flow here. Yes, it flew here. And now the pump has automation has detected that there is enough magma here, so it has started, and there is not enough magma in the reservoir. So plumbing wise, you can see we are pumping 10 kgs of magma blobs, 2 blobs of magma and 1 blob of naphtha. This blob of naphtha should drop here because here, if I set the filter correctly, plumbing wise, magma goes up, naphtha goes here. So this naphtha is also in contact with this naphtha that is sitting on the floor. So that should allow it to cool this liquid filter as well as the pump. And this should continue while there is enough pressure. So this is the whole automation, and now we have magma nicely stored in our reservoir. And then we can use this magma later on to do anything that we want. It took a little while to get this all primed up, but once it is primed, it works like a charm. And this should work non-stop. I made everything, if you check on materials, I made everything out of ceramic wherever it matters. This is obsidian, this is ceramic for no good reason technically, this can be obsidian. Why is there steel here? Uh, Let me clean this up, there is some steel stuck in this tile. So I'm just going to connect the pipe here. I already connected this pipe to our main water supply and I'm multiplexing the pipe for now. And we should put some water in here, and the goal of this steam room is to just get it hot enough so that we can heat up the CO2 before feeding it to our slicksters. We haven't started pumping CO2 just yet. We want to get the steam room hot and nice. Right now we have a decent enough igneous rock, 1300 degrees Celsius, that we can ignite anything. So let me just clean this up and we can start working on that. Power wise, I'm just going to reconstruct the transformers that I deconstructed earlier, because now we should be able to afford the temperature and it should heat up really fast. You can see it right here. In the meantime, I'm going to reconstruct this thingy that is our perpetual storage for all the molten slicksters, but that is going to take some time. Come on. And on ONI, we are running actually very short on calories. And it turns out that Joshua is not able to sustain himself. Let's do one thing, Joshua. Let's bring you back home now for temporarily. We don't really care that much. You are exhausted. Stamina 7%. Yeah, 8%. You should be okay. Come on. Stop acting up. Come back home. Yeah, he's highly stressed at this point. So Joshua, teleport back home. At least we don't have to take care of Joshua there. And you are not allowed to get out. You are just going to stay in. We are not really good on calories because some of our ranches have been getting neglected. Right now, this is 8, this is 3. And this is only 2. So we don't have enough hatch population coming out because I've stopped feeding 3 of the ranches. We were really short on some resources, especially granite and igneous rock. So right now we are barely cutting through it. Oh shit. Yep, there's way more than enough water in our loop. So let's just start heating it up. So I'm just going to connect the aqua tuner and this way. Done. So this is going to circle around and cool the polluted water to, let's say, 0 degrees Celsius, so minus 14. We are generating a little bit of CO2 just because we have moved all of our power production from all the way over here to here. And these generators should provide a little bit of CO2, but not enough. We want to pressurize this area up to 20 kgs of CO2, and it's going to take a lot of time. Right now we have 19 grams. So what I am thinking is, why not use this carbon dioxide geyser? And it should start flowing in really fast. So you can see this has 40 kilograms of pressure of CO2 right here because we uncapped this geyser God knows when, maybe a long time ago. So all we need to do is just move it here and it should allow us to push all these nasty gases up. We can just put some gas pumps here to get the clean CO2 and push it back down in this chamber. Also, this CO2 is pretty chill. Right now this is at 23 degrees Celsius. Rest of this is burning 44 degrees Celsius. So that would be a great boon for us. So while the CO2 makes its merry way all the way down, we can take a look at some of these things. So right now we have 3 or 4 slicksters over here and one long hair slickster lava that I kind of want to rescue because they will die off if we don't do that. So what I am going to do is just make a liquid lock here to go to this place, because we have a spore kit here and I don't want the spore kit to destroy our CO2 with all the zombie spores. So while everything else is happening, let's take a look at this setup. So what we have here is a big facility for producing CO2 at industrial scale. So we can fill these three levels with whatever things we want, including a petroleum generator, a natural gas generator, and everything. Everything here is cooled by this aqua tuner, which can provide chilling, and this is configured using our buffer tank. So how this chilling works is, we set this to a very low temperature like 0 degrees Celsius. So aqua tuner is always going to chill polluted water to 0 degrees, and that 0 degree polluted water will come here, go through this loop all the way back into the tank. So this is a storage buffer of chilling. Now this polluted water will first try to scoot onto this secondary line using this bridge. Now this bridge will only allow polluted water to go inside our industrial brick if there is a water blob that is empty in this pipe. So how does the blob gets empty in the first place? It gets empty using this liquid shutoff. So what this liquid shutoff does is, there is a sensor here where I'm setting it to 20 degrees Celsius. So if water in this loop, if it becomes more than 20 degrees Celsius ever, this shutoff will turn off and it will shunt that polluted water outside of loop. Otherwise that polluted water is going to keep on rotating in this loop. And as soon as polluted water gets above 20 degrees Celsius, it goes here, goes to this bridge, jumps around here and merges with this bridge. You see there is a space here that I left for future expansion, where I'm going to add yet another aqua tuner here if needed. But otherwise what it will do is, it will take one blob of liquid that is coming from this aqua tuner and one blob of liquid that is coming out of this loop, and it will just shunt it down back into our storage buffer or a chill buffer. So this way we can maintain multiple temperatures using just a single pair of aqua tuners. So this, I can leverage this mechanism to chill our ranches up. I can chill it anywhere else as well. So I can control what temperatures different ranches can be by just passing one chilled column of polluted water and using this loop setup to chill everything else. Now to pump out the CO2, what we have here is a liquid bead pump. So if I click on materials overlay, you can see we have a blob of liquid that is coming out of this vent. So we have a liquid pump here that is going to pump up a lot of oil in this pipe. Now we have throttled that oil to flow out at a rate of 10 grams per second only. So this way only 10 grams of oil is going to go up. So that way we have a lot of buffer here for many cycles, because each blob contains 10 kilograms of oil. And this oil is coming out of this vent, and the ONI mechanics of physics works that way that if a liquid is coming out of a vent which is concealed on three sides, 1, 2, and the bottom side is a mesh tile, it will always form a blob. And what this blob does is, it pushes all the gases that are there in this section one tile above. So it replaces gas with the water blob. And we want this mechanics to shunt out everything up this way. So that's my hope, that as soon as I open this up, it should shunt out all the CO2 up this way to feed to our ranches, right? So let's try that for a second. What I need to do is open up this section for that. So I'm just going to move this one tile above and deconstruct this and replace it with a normal mesh tile. And materials wise, you can see gases, come on, yes, you can see CO2 has started flooding here because this liquid pump is pumping CO2 all the way up and through this mesh tile into a ranch. And this way all of this CO2, once it goes here, will get heated up. You can see it's heating up to 114 degrees Celsius, and right now here it is at 52 degrees Celsius. If I click on temperatures, you can easily see the difference. It is chilled here, but as soon as it gets out here and gets heated by this steam brick. So essentially we are reusing the heat from all of our coal generators and petroleum generator, natural gas generators, and heating up that CO2 before feeding it to our slicksters. And that's the whole idea of this dual ranch. Now I just need to clean it up a little bit. I need to remove this wire, put a mesh tile, and have some automation here. Reason for that is I don't want this CO2 to actually leave when we do not have enough CO2 in this chamber. So what can I do is put this airflow tile over here and a mechanized airlock here. So this way, also there is a blob of naphtha here. You can barely see it because of airflow tiles, but if I click on liquids, you can see there's a blob of naphtha here that is preventing air or CO2 from directly going here. Instead, CO2 will go bottom down using this mesh tile, come here and go up here. So now there are two airflow tiles that will allow CO2 to come from this way, enter this mesh tile, and if this door open, it will enter this mesh tile and go here in our stack. So how is this door activated? Using an atmo sensor. So let's say if I say if CO2 pressure is, let's say, above 500, I'm just doing it for testing. And materials wise, I'll click on gases and you can see how CO2 will start flowing. So you can see here it's very hard to see, but overall this temperature or this current pressure sensor is going down and down and down. We started at 1 kilogram and now it's 780, and it will keep on going down. So this is the reason I wanted to have a lock here, because I don't want polluted water to off gas. So that's why I'm going to keep it to 3000 around here, or 3 kilograms. So that is a safe enough pressure for us to have in this chamber. If there is more than 3 kilograms of pressure of CO2, it will pump everything up into our ranches. Otherwise the CO2 will stay here and will prevent all the polluted water from off-gassing. Now what we can do is we can start moving some of these natural gas generators over here. I am just going to make them out of copper ore because that's the cheapest that we have, and we don't really need any better materials because we have cooling that is running around here. So if I make 3 of these generators made out of copper ore, that should be more than enough to support our needs of power right now. And I'm going to remove all of these generators from here because we don't need them anymore. They're just going to generate polluted water that is going to get dropped over here. All the CO2 is also going to get dropped using a high pressure gas vent right here. We don't really care about that. And natural gas is going to come directly from our natural gas storage right here. And there we have it. We are just waiting for the pressure to rise up to 3 kilograms before I kickstart this process. But everything is plumbed in. We can see ventilation wise we have plumbed in. Our natural gas output is plumbed out directly to the high pressure gas vent, and we have connected it to power supply. In the meantime, I just discovered a nice thing, and we have our first molten larva egg. So let's kickstart this process. Remove. I want to incubate my molten larva. Where is this? Here, incubate. So now we can incubate larvas and kickstart this ranch. This ranch is still not 100% functional, but it should work. And all the petroleum that they will generate by eating this carbon dioxide is going to flow down here. It cannot go here, so it should go technically all the way over here and just flow it down over here. And that's my hope. I am also going to put a small brick tile somewhere over here just to prevent petroleum from going all the way here, because I don't want petroleum to block this thing up. So I'll just remove one tile from up top, put a tile down. Yeah, that's good. We are also going to put some temperature shift plates here because the temperature is not evenly getting spread out to the CO2. So you can see there is a lot of area to heat and the CO2 is still have a lot of work to do. So I'm just going to put a couple of temp shift plates around here. That should help out spread the temperature from this steam room all the way down. The steam room currently is very chill. It's 137 degrees Celsius only. But that should heat up over time as we generate more and more heat over here. Well, I made a huge mistake. I did not put automation wire here and this natural gas generator kicked in and it started churning out polluted water. So this polluted water is all the way over here and it is off gassing. But somehow I got lucky enough that it only created polluted oxygen over here and all the polluted oxygen that is getting generated here is getting deleted automatically because the amount of polluted water is not significant enough. So that's lucky, I guess, but I need to make sure that there is no polluted oxygen in this area because that's gonna mess up a lot of things. But on the bright side, Estes Falls is working perfectly. Now we have two gases, one gas here and one gas here. So this should technically be full and it can always keep on pumping more and more polluted water in here. So there's some bright side to a mistake. But now right now I just stopped working on this generator and hopefully this CO2 should catch up enough that it will stop off gassing. And it is up and running. All we did is we just pumped up excess CO2 that was here, which is coming from our CO2 vent that was flowing all the way over here. We have like how much 8 kgs of CO2 right now. So I just put a pump here with the automation saying that if the CO2 is up to this level, this pump will activate and pump all the CO2 back here. This is just a temporary measure till we pressurize this area. We want to pressurize this area to at least 3 kgs very fast. So that's up and running and done. With a little bit of help from our outside CO2, the pressure here is up to 3 kilograms. It should rise up here, but it is good. So all we can do is we can just connect this generators now automatically with our automation. So automation connect. Now these generators will run forever and we can get rid of some of this coal generation. And now we have CO2 as well as polluted water generation. So these generators consume 90 grams of natural gas per second and generate 67 grams of polluted water and 22 grams of CO2 as compared to a coal generator which consumes 1 kilogram and generates 20 grams of CO2. So this is generating more CO2 and for free. So why not? And the worst fear came alive. 2 blobs of polluted oxygen somehow escaped from here and are accumulating here. The easiest way I think to deal with it is to make kind of like a gas hood. So I'm just going to make a tile like this where I'm going to deconstruct this later on. So all this gas should accumulate in this tile where we can delete it later on by building a tile on top of it. So that's the hope. And done. So polluted oxygen is right where I want it to be. I'll just make one tile here that is going to trap it and another tile here to delete it. We'll just build a tile here and that should be the end of CO2. Okay. Tragedy avoided. I also put a buffer gate over here, so now whenever we go over 5000 it should open and close this up for 10 seconds. So it doesn't open and shut very frequently. So we'll export CO2 in bulk or batches. Finally, we have our molten slickster ranch started. So we have a crater drop off that is going to be pretty regular. It's going to have molten slicksters coming in and this auto sweeper can pick up any eggs that fall on this side or on this tile and push it back in this conveyor loader. This conveyor loader is configured to carry only eggs, and all the eggs are going to get carried and shipped to this section and this tiny hole where we will collect all the slickster eggs, be it a regular slickster or a molten slickster. From there, this conveyor loader can or conveyor sweeper, auto sweeper can take place. So job of this auto sweeper is basically to take anything that is here, including meat as well as all the eggshells. So if I say eggshells, okay, this conveyor loader will take up everything that is here and push it back, and this basically goes into our evolution chamber. Now we also want to get rid of all the normal slickster eggs. So I am going to do is, egg wise, I'm going to put all the critter eggs except for molten slicksters. So this way only the molten slicksters will stay here, consume all the CO2 and convert it into petroleum. That petroleum is going to flow in here, meet with the petroleum generated by ranch slicksters, and everything will flow down this way and collect at the bottom of the map. So this way the first priority of the CO2 is going to go towards the ranch slicksters, and once the ranch slicksters have finished up eating all the CO2, that CO2 is going to get fed to the normal or excess slicksters. So this way we can have a constant population of slicksters, tame slicksters, fed but ungroomed. This is almost like a infinite meat hack. As long as you have CO2 coming in to feed these slicksters, they will keep on generating an egg during their life cycle, as well as give you free petroleum. So that's why I love slicksters so much. So this is the overall setup of slicksters. Here I'm going to increase the priority of this to have 2, so all the meat and other eggs get shipped out, and priority of this is gonna be 1. And here I can select all the critters that I want to get picked up from here, and once we have a normal molten slickster, we can choose that one over here. They will get picked up from here if the ranch is empty. This sensor is sensing the ranch currently has 1 critter. If it is less than 8 critters, it will automation will enable this pickup, and duplicate will come in, pick up a larva or a molten slickster and bring it into the ranch. And that's the overall end-to-end automation. We also finished up yet another refinery. In this case, I just put a auto sweeper over here and moved all my iron over here. So that way we can refine iron right here in this refinery and only refine steel here. So that way both of them, the refineries can work simultaneously. I left my pips running because I got more pips egg. They evolved into pips, and now they are planting up all the things that we need. So right now I just accidentally let some mellow seeds over here. So pip have planted that one. They have planted yet another one because I left 2 natural tiles here. So there are literally 3 plants here without me doing anything. So why not just create yet another park? So I am going to use diamond this time, because why not? We are rich enough to afford diamonds, and just make this a nice natural park. Just trying to get my pip to plant something over here. If you take a look at this room is 86 tiles, which is slightly bigger than a park. So my options were either to squeeze one of these plants in this room or try to plant something else in here. And there are only 2 natural tiles, unfortunately, and third one is here. So what I was thinking is, if I click on pip plant overlay, this is a valid tile. So I just left some pinch of pepper nut seeds over here and hoping the pip would plant it here. But somehow the pip decided that it wanted to plant something over in my kitchen. If I take a look at pip plant overlay, yeah, definitely. Oh well, now we'll have, I guess, a pinch of pepper nut. plantation in the kitchen. Doesn't look bad to me actually. It kind of feels like a perfect place to be. Yep, it's growing. Wonderful. Yeah, natural beauty. Doesn't hurt. Looking at the time, I think it is a good place to end this episode. I hope you folks like this. Hope to see you folks next time.